There, Mr. Sutton here with the IM3 Honors 3-2 Part 1 homework solutions on adding and multiplying complex numbers.
To subtract these complex numbers, we have to distribute and combine like terms. So for our first parentheses, we're just distributing an invisible 1, so that's just -3 minus I without a parentheses. For the second one, though, we are distributing a -1, so this is going to be -5 plus 2I. And then combining like terms, -3 minus 5 is -8, and -1I plus 2I is +1I. To add these complex numbers together, we just have to distribute some invisible 1s and then combine like terms. So basically, we can just lose the parentheses here because we're just distributing 1 to it. So we have -7 plus 7I with no parentheses, plus 7 minus I. Now to combine like terms, -7 and +7 gives me 0. And then 7I minus I is going to be 6I. So we've just got 6I. To add these complex numbers together, let's first get rid of the parentheses. Since they're each being multiplied by an invisible +1, we'll just drop the parentheses. So we have -6 plus 4I plus 2 minus 11I. And at this point, we just combine like terms. -6 plus 2 is -4. 4I minus 11I, that's going to be -7I. To subtract these complex numbers, let's first get rid of the parentheses. This first one drops off pretty much for free. We have 8 minus 2I. This next one, we need to distribute a -1 to those terms. So this is -1 plus 6I. And now we can combine like terms. 8 minus 1 is 7. And then we have -2I plus 6I. That's going to be a +4I. For this problem, before I can add or subtract these together, I have to simplify all the powers of I to get either a real number or something with just I to the first power. So to do that, I just have to figure out where in the cycle of 4 each of these exponents is. If we take 7 and divide it by 4, we get a remainder of 3. So this is really equivalent to 8I cubed. For the next one, 68 divided by 4, that's actually a remainder of 0. So this is really equivalent to -13I to the 0. And then 17 divided by 4 gives a remainder of 1. So this is really 6I to the 1. Simplifying a little bit further, I to the third is really -I, so this is -8I. I to the 0 is just 1, so this is just -13. And I to the first is just I, so this is +6I. At this point, we can combine these imaginaries together, these i's. So we have -13 is just by itself, and then -8I plus 6I gives me -2I. So if I want to write the real number first, I can write -13 minus 2I. Before we can add or subtract these together, we need to simplify all these powers of I. Now here we're just figuring out where we are in that cycle of 4. So 64, if you divide that by 4, you have a remainder of 0. So this is really the same as 83I to the 0. And if you divide 18 by 4, you would have a remainder of 2. So we can write plus 69I to the 2. And finally, 87 divided by 4 gives a remainder of 3. So this is -34I to the third. Now let's go ahead and simplify a little bit more. I to the 0 is just 1, so 83 times that is just 83. I squared is -1, so this is really -69. And then I to the third is -I, so this is really +34I. And one last step, we can combine these real numbers here to get 14 plus 34I. To multiply these imaginary numbers together, we're just going to multiply the coefficients and then use our exponent rules on the i's. So we have 4 times 7 is 28. I times I is I squared. And 28I squared, because I squared is really just -1, we can simplify this to -28. To multiply these imaginary numbers together, we multiply the coefficients and then use our exponent rules on the i's. So -3 times 10 is -30. I to the third times I to the 7, we have to add the exponents. So this is I to the 10th, so -30 I to the 10th. And then we have to figure out where we are in that cycle of 4 for simplifying powers of I. So 10 divided by 4 gives me a remainder of 2. So this is equivalent to -30I squared. And since I squared is really negative 1, this is just negative 30 times negative 1, or simply positive 30. On this problem, we're multiplying these complex numbers together. So let me take care of the coefficients first. We have a 1 times negative 2 times negative 8, giving us a positive 16. And then I times I times I is I cubed. Now I cubed is really the same as negative I, so this can be simplified to negative 16i. For this problem, to raise 2i to the 5th power, because two things are being multiplied in a parentheses with an exponent, we have to raise both of these things to 5 using our exponent rules. So 2 to the 5th is 32, I to the 5th is I to the 5th, but we're going to simplify that now because we know that all powers of I, 2 and higher, can be simplified. So to figure out where we are in the cycle of 4, we divide 5 by 4 and find the remainder. That's just a remainder of 1. So this is just equivalent to 32i to the 1st, which is just 32i. For this multiple choice question, we want to know which of these expressions is equivalent to 2i squared plus 3i cubed. So I squared, we know that's really negative 1, so we can write 2 times negative 1, plus we know that I cubed is really negative I, so this is 3 times negative I. So then I can rewrite this as negative 2 minus 3i, and that is going to be answer choice A. For this multiple choice question, we want to know which of these is equivalent to I to the 50th plus I to the 0. So let's simplify this I to the 50th before we do anything else. Since i's go in cycles of 4 in terms of their exponents, we just need to figure out where in the cycle we are. If we divide 50 by 4, the remainder to that is 2. So this is really I squared in disguise. And now I squared we know is negative 1. I to the 0 is positive 1, so we're doing negative 1 plus 1. And those cancel, leaving us with 0, giving us choice D.